Okay, now we're going to talk about averages on the bell curve. So do you remember what this is called? This is called the normal distribution. There's an infinite number of these. Some of them are more peaked than this, and we call those leptokurtic. Some of them are flatter, and we call them platykurtic. But we'll say that this is the right in the middle. That's called mesokurtic. That was discussed in chapter 2. Remember that? Okay, so where would we find the averages, mean, median, and mode, if we had a perfect normal distribution? Well, this is hypothetical because we never get a perfect normal distribution. But let's say, hypothetically we did. Where would we find the mean, median, and mode? Well, the answer is right smack dab in the middle. They're going to equal the same value. So if this is a hypothetical, normal distribution that goes from negative infinity to positive infinity, then that means that the mean, median, and mode all equal, what is it? Negative infinity, positive infinity. What's in the middle? 0. Okay, so let's make sure you understand why this is the case. Okay, so let's look at the mean. We said the mean balances the scores, right? It's the center of gravity. The normal distribution is symmetrical. That means if we were to cut it down the middle here and fold it in half, this half would be the same as that half. So if the mean is the center of gravity, that means the weighted sum of scores below it will equal the weighted sum of scores above it. It's going to be perfectly balanced. If we put a fulcrum here, this normal distribution is perfectly balanced. So that means the mean is located here. That's where the fulcrum is. Now, the median is the score that cuts the area of the curve exactly in half. So I defined it earlier as the median. With the median, it cuts the scores in half, right? But here we have scores on the x-axis, but some of those scores occur infrequently and some of the scores occur a lot more often. So you can't just order your scores and find the middle. You have to say that the median, you have to phrase it as the area. So the median, if you were to draw a line up here, whatever that shaded area is, right, that shaded area is going to be the same size as this shaded area. And again, it's because when you look at the median for this particular distribution, you have to take into consideration that you just don't have scores. Some scores occur once, some scores might occur 1,000 times or more. So you have to look at the area under the curve. So because this is symmetrical, draw a line down here, and this area will equal that area, which means the median is right smack dab in the middle. And the mode is probably the easiest to understand because the mode is just the most frequent score, right? So what you do is you locate the highest point of the curve. This line is representing frequency, so you go up to the highest point, draw a line underneath, and guess what? It's right smack dab in the middle, right? So this is why the mean, the median, and the mode are all the same, okay? All the same score. When would you use the mean, the median, and the mode? Remember, I gave you a little bit of a preview, and I said that which one you use depends on your scale of measurement, right? Whether you have nominal, ordinal, interval, or ratio data. If you have nominal, the only thing that you can calculate is the mode, right? The most frequent score. If you have ordinal data, well, now the numbers mean something in terms of rank order. Oh, we have rank order information. If we have rank order, so we can order the numbers from lowest to smallest, that means we can calculate a median. But that's the only, we can also calculate the mode, I should say. All right, but that's all you can do with ordinal. So with nominal, you can just do the mode. Ordinal, you can do the mode or the median. If you have interval or ratio data, then sky's the limit. You can do any one of these, mean, median, and mode. But I am going to emphasize over and over again, for a little while anyways, that if you have a choice between mean, median, and mode, which one should you calculate? The answer is the mean. Always use the mean, if at all possible. Now, we are going to talk about when would be a time when you shouldn't use the mean. All right, and I'm not going to go that far today because I think we've covered enough material. I'll give you a little bit of a preview. All right, whether you calculate the mean, median, or mode depends on the shape of the distribution as well. So it's not just based on NOIR, N-O-I-R, the scale of measurement. It's also based on the shape of the distribution. And we already know if your distribution is normally distributed, all right, mean, median, and mode are going to be all the same value, but that's theoretically. In the real world, you're not going to get this perfect shape. But if it's more or less normally distributed, that means your mean, median, and mode in your real data set are going to be close in value. They just won't be identical. So you might think it doesn't matter. I can report any one of them because they're so close. Well, it does matter. All right. Report the mean. And next lecture, we're going to talk about why the mean should always be reported, if at all possible. And we'll also learn about a specific situation where reporting the mean would actually not be a good idea. It would be a little bit deceptive, if you will. All right. So we're stopping here. Let me know if you have any questions, and we will definitely be wrapping up chapter 3 next time we meet, and starting chapter 4. And after chapter 4, I'm sure is something you all can't wait for, and that will be your first progress test. But don't get discouraged because I will throw a life preserver out to anybody who screams help. Okay, see you later.